All right, so continuing on with the solution, this is where we left off. The integral of e times ni of x dt, so across the entire solution domain, is equal to the integral from x1 to x2 of the second derivative of t squiggly with respect to x plus f of x, all times ni of x dx. Okay, so this is what we have. This is what we want to simplify. Well, for a few things we can do to simplify. First, we can take this to the other side of the equation. So doing that, we have and split it into two integrals. So the integral from x1 to x2 of square t x squiggly times ni of x dx is equal to negative integral from x1 to x2 of f of x and I of x dx. Okay, great. Now at this point, we have the two sides, and I want to take a little bit of a closer look at this. We can simplify this out quite a bit, but in order to do that, we're going to have to remember a little bit of calculus. Actually, integration by parts. So just to remind you, the formula for integration by parts is any integral from a to b. A lot of times it's represented as an indefinite integral, but we'll do it as a definite integral because it makes more sense, because that's what we're doing here. The integral from a to b of u dv is equal to u times v evaluated at a and b minus the integral from a to b of v du. Okay? And the tricky part here is always picking the v, or picking your u and dv. But let's do it. So we say, if we say u is equal to ni of x and dv is equal to d squared t tilde dx times dx, well, so the dx, then that would mean that our du is d with respect to x of ni of x, and our v is going to equal the derivative of t with respect to x. That was our, and that's still times dx. So when we plug that into this formula, we don't need to represent the left-hand side, because that's what we already have here. We just have a new right-hand side. So uv, so that'll be ni of x times v d t squiggly dx dx is minus the integral evaluated at x1 x2 minus the integral from x1 to x2 of v du. So that'll be v dt dx ni of x. I'm just going to put the dx at the end here, where it belongs. As I could have put it with this dt squiggly. Okay, and that's what we get. And we have to remember here, I probably should have written this out. This is for all the way along here. For I equals, in this case, we just had 2. Remember, we had here, we defined our t squiggly n1 and n2. So when we're working with it down here, it's just for I equals 1, 2. And it would go on if we had more functions in our representation, but we don't. So this is for I equals 1, 2, well, just 1 and 2. And so what we can do is actually start plugging this in. So this is 4 I equals 1, 2. Now let's write it. So the first thing then that I'm going to work on here, let's get a different color so we can see what we're working on. I want to work on this part right here. That part. Okay. So ni of x, so let's do it for I equals 1. So n1 of x dt squiggly dx, and that is evaluated from x1 to x2. So that means it should be equal to, let's see, n1 dt dx. So that'll be n1 of x 2 dt squiggly dx minus n1 of x1 dt dx. Okay, so there's a couple things to notice here. First of all, n1 of x2 is equal to 0, and 1 of x1 is equal to 1. And you can see this if you go to this plot here. So if this is x1, I mean, we could look at any element, but see, if this is x1 and if this is x2, then this is our n1, right? So our n1 evaluated at x2 is 0. See that? And our n1 evaluated at x1 is 1. The height of these is all 1. So that's what's going on here when we set that to 0 and that to 1. We can also do this. I'm running out of room here. We can also do this for I equals 2. We can say n2 of x dt squiggly dx evaluated from x1 to x2 is equal to n2 of x2 dt dx minus n2 x1 dt dx, and this again is going to simplify where this is going to equal 1. Not this second term, right? This second terms are still there, but it's just this first term that I'm talking about, and that's equal to 0. Okay, now let's plug this back in to the original equation and simplify, but let me just move over to another column so we have some more. So here we go. So what we're going to come up with is, and I'm just going to write this out because we've already started writing it out with n1 and n2. So it'll be the integral from x1 to x2 of dt dx dn1 dx, that's of x, this is dx, and then here we have the integral from x1 to x2 dt dx dn2 dx x, that, and then as we can, and I'm going to bring the other term to the other side of the equation, so that is going to equal minus dt dx, and that's t of x1, and this is dt x2 x, all right, plus, and then we have our two integrals. Integral from x1 to x2 of f of x and 1 of x dx, and integral from x1 x2 f x and 2 of x dx. Okay, now there are a couple other things that we can notice here. First of all, we can notice this term here. So this is really nice because these terms are actually our boundary conditions. These are the conditions, and so we can just plug those right in. We've already incorporated them. The other thing to notice is on this integral here and this integral here, we've introduced the we've reduced the order of this derivative by 1, so that simplifies it greatly. The other thing that you can notice is this is going to be, well, especially right here, okay, this is going to be really easy to integrate. It's, well, two things, and this is really easy to take the derivative of. This is really easy to take the derivative of because it was just a straight line. Okay, so the derivative of that's easy. That'll just be n1, but it'll be written out in terms of x. So, and the other thing is this integration is just the trapezoid rule. So really we just have to do the trapezoid rule. So that's a nice thing that we can. Now the other thing is we can actually write this. So as I mentioned, these derivatives are fairly easy. Let me just give you what the final form looks like. But let me just write it all out so you don't have to wait for that. All right, so here it is, and they usually call this. They usually call this the element stiffness matrix. Stiffness matrix. This is the boundary condition. And this is the forcing function, or we'll just call it external effects. So that concludes step 2. As I promised, if you go back and look at our master list of to-dos here, as I promised, step 2 was the most involved. But now that we've gotten through that, we can go through and see how all